In today's lesson, we are going to be looking at kind of a basic math concept, but again, it doesn't hurt to kind of review it. We're going to be looking at working with integers. So this is just going to be working with positive and negative numbers. So just as a warm-up, taking a look at these two these four kind of expressions, which one doesn't belong? So take a second to think about each one and think about which one doesn't belong. And if you're not sure, again, you could just start by working out and going through and actually solving each expression. So 8 minus 3 is 5. Negative 3 plus 8 is 5. Negative 3 minus 8 is negative 11. And negative 2 minus negative 7 equals 5. So there's different ways you could have done this. So you could, by doing this and by solving it, you could say, well, the odd one out is this one, because all the other ones add up to 5. You could have also said, well, maybe this one doesn't belong because the two numbers that we're dealing with are not a version of 3 and 8. So again, there are different ways you could go about actually figuring this out. There's different ones you could do. You could say maybe this one is the odd one out because we're adding numbers here, whereas all the other ones we're subtracting. So again, there's different solutions. There's not one correct way. But based on what we're looking at today, if you went through and you added or subtracted them, that's kind of what we're going to be looking at. Again, as another warm-up, choose any negative integer, so any negative number, and use these two color counters to represent it in as many ways as you can. So again, this might be a little bit more difficult because you can't really manipulate these, but let's just say our negative integer will be negative 4. An easy way to represent negative 4 would be to have 4 negative 1 blocks. Another way we could have negative 4, let's say we have 5 negative 1 blocks and a positive 1. Or let's say we have 4 positive 1s and 8 of the negative 1s. All of these work out or represent negative 4. So you could go about and do many different examples or different things, representations of a negative integer using either just the negative numbers or a combination of the negative and positive ones. And really what you're doing is you're adding and subtracting, or sorry, adding at least positive and negative integers. So we're not really going to look too much into it other than looking at kind of some examples to just get familiar with, again, using these terms or these numbers again. So example 1, early in the morning, the temperature of the outside air is negative 7 degrees Celsius. By 2 p.m., the temperature had risen to by 10 degrees Celsius, and by midnight, it then dropped 4 degrees Celsius. What is the temperature at midnight? So there's a couple things, and anytime we have a word problem, something that we might want to do is we want to highlight or underline kind of key important things. So in early morning, it was negative 7. By 2, it had risen by 10 degrees. And then by midnight, it had dropped 4 degrees. And then the question is asking, what is the temperature at midnight? So again, some important things we just want to highlight there. Now there's different ways you can solve this. You could look at it very mathematically and say, okay, well, I start at negative 7. It rises by 10, so I'm going to add 10. And then it drops 4, so I'm going to subtract 4. So the temperature at midnight will equal negative 7 plus 10 minus 4. So in this case, our temperature then becomes -1 degrees Celsius. That's one way you could do it. If you're having trouble with that or visualizing it, maybe you prefer to use a number line. So 1, 2. So maybe you prefer to use a number line. You know you're starting at -7. We're increasing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 2 p.m. or by 2. So we start at -7, we increase 10 degrees to get to 2, and then we decrease or drop 1, 2, 3, 4 degrees at midnight. So that means we end up at -1. Again, different ways to figure it out, especially if you're trying to do this in your head. Example number 2. Tim cuts neighborhood lawns in the summer and charges $20 per lawn. On Monday, he cuts 1 lawn and spends $5 on ice cream. On Tuesday, he cuts 2 lawns and spends $15 on gas. How much money does Tim have overall at the end of the day? Again, with a word problem, we want to highlight kind of some important things. $20 per lawn is an important thing. On Monday, he cuts 1 lawn and spends $5 on ice cream. And on Tuesday, he cuts 2 lawns and spends $15 on gas. And then what we're trying to figure out is how much money does he have overall at the end of the day on Tuesday. So again, different ways you can think about this, but we may want to focus on splitting it up onto 2 days. Monday and Tuesday. On Monday, he cuts 1 lawn, so he earns $20. But he spends $5 on ice cream, so we have to take away $5. We get positive $20, but we take away $5 on Monday. And you could say, okay, well, at the end of Monday, we're left with $15 in total. On Tuesday, he cuts 2 lawns, so that's $20 twice, or you could say $20 times 2. But then he spends $15 on gas, so we have to take away 15. So because we have to take away that 15, he only makes in total $25. So at the end of the 2 days, when we add them all up, we have $15 plus $25 equals $40 in total. There are other ways that you can solve this question as well. The other way that you could have solved this, or one of the other ways, sorry, is not even worry about it being Monday and Tuesday separately, and just add them all up together. So again, understanding that when he's cutting lawn, he's earning money, so it's in the positive, and spending money would just mean the negative. So in this case, we could say earnings, or E, equals $20 minus $5 plus $20 plus another $20 and then minus $15. And again, from there, we would still end up with our total of $40. So again, different ways that you could do this. You could sort it out into adding all the positives and then adding all the negatives and seeing how much do we take away, right? So $60 earned minus $20 spent would leave us with the 40. So again, different ways that you can reason through these types of examples. When we're dealing with integers alone, it may be easier to help visualize it with a number line. Right? So again, for the first one, 10 minus 12, or you could just in your head jump right to the answer is negative 2, or you could think, okay, I'm going to start at 10 and go back 12 spots and end up at negative 2. You could also think, well, I need to take away 10 just to get to 0, and then I still have 2 more to get to negative 2. Again, different ways you can think about it. Negative 7 to positive 3. And here you could just, again, jump to the answer of negative 4, or understand that when you're starting at negative 7 and you're adding 3, you're going in the positive direction, which takes us to negative 4. Negative 7 plus 15, again, same thing. Negative 7 plus 15. You could quickly do this in your head and get to 8, or again, start at negative 7 and then jump 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and you end up at 8. So again, different ways you can do this. And again, yes, you could be using a calculator to quickly figure this out, but being able to do this mentally will help make some questions faster and just help you become more comfortable with solving questions. What about if we're dealing with subtracting negative numbers? How can we explain this using tiles or using using a number line? Right, so if we have 1 minus negative 2, again, if we're going to use our tiles, we have our positive 1, and we want to subtract negative 2. So when we've added, if we were to add negative 2, so that's just an example, 1 plus negative 2, that one would be easy because we would just draw something like that. We would have 2 that cancel out, and we're left with a negative 1. But we want to subtract negative 2. So you could think of this as a double negative, minus 2, or minus negative 2. Think of that as a double negative. And what does a double negative really mean? So if you're told don't not do that, that means do it. Right? So if someone said don't not come to school, right? That they're basically saying come to school, just in a very convoluted way. So if we think of it, if we do the opposite of what it's telling us, if it's doing the opposite of subtracting negative 2, then maybe that would mean add positive 2, which in this case would equal positive 3. On a number line, if we were to start at 1, and normally when we're subtracting, we would go in the negative direction. However, when we're adding a negative, we would go in the negative direction. However, because it's the double negative, we're going to do the opposite, which would be going in the positive direction of 2, which would bring us to plus 3. And if you do check this on your calculator, you would see that this does work out. So you could think of the minus and negative as a double negative, which kind of cancels out, which basically means you're doing the opposite. Or in this case, we're just going to add 2 instead of subtract 2. So again, just something to think about when we're dealing with those negative numbers. So again, let's look at examples here. 8 minus negative 3. Double negatives, so we're going to do the opposite. We're going to do 8 plus 3, which equals 11. And again, you could do that on your number line. 8, instead of going to the left 3, I'm going to go to the right 3. 1, 2, and 3, which takes us off, or 11. Negative 10 minus negative 3. Again, we see that double negative. So we can change that, or no, they cancel out, and just do negative 10 plus 3. So we're at negative 10. We're going to move 3 units in the positive direction. Or again, you could just do that quickly mentally, and negative 7. Again, if you're unsure about that, again, you do have the calculator, so you can double check your answers. And again, hopefully by doing this more and more, you become more confident in doing this quickly in your head. Aside from adding and subtracting integers, we're going to look at multiplying and dividing integers. So again, multiplying and dividing positive and negative numbers. So again, just another warm-up to think about, okay, which one doesn't belong. So again, take a second to work through this. Again, as we saw with the last one, there's multiple solutions depending on what you're looking for. Right. So again, you could say this one is the odd one out because this is using the x as a symbol for multiplying, where everything else is using brackets. You may have gone through and said, again, this one's the odd one out because this is the only one with a positive 4. All the other ones have negative 4s. You could have gone through and actually determined what each one was. 4 times negative 3, or sorry, 3 times negative 4, which is negative 12, negative 12, negative 12, positive 12. And said, okay, well, this is the odd one out because it's the only one that's not negative. Or you could have said, okay, this one is the odd one out because the 3 is secondary and the negative 4 is first, whereas all the other ones, the 3 term is first. So again, there's many different ways that you could go through and figure this out. If we're just focusing on multiplying and dividing, then I would say that this last one is the odd one out because the solution is different from the other two. Again, when dealing with word problems, so we're going to be focusing on multiplying and dividing. When we're dealing with word problems like this, we want to focus or read through it once and then highlight any important information a second time. So this week, Tim was busy. On Monday, Tuesday, Wednesday, and Thursday, he cut 5 lawns each day. On Tuesday and Friday, he cut 7 each day. He had to buy gas 6 times, costing $15 each time. He bought a $10 lunch on each of 3 days. And he still earns $20 per lawn. He has his eye on a new bike that costs $200. Will he have enough money to pay for it? So again, it's a very wordy question. There's a lot of things that we want to take into account here. So on Monday, Wednesday, and Thursday, he cut 5 lawns each day. Tuesday and Friday, he cut 7 each day. He had to buy gas 6 times. Gas costs $15. He also bought a $10 lunch on 3 days, earns $20 per lawn. And the question is asking, will he have enough money to pay for it, which is his $200 bike? So, again, different ways that we can go through this. We could focus on, again, what we did before, where we focused on Monday, Tuesday, Wednesday, Thursday, and Friday. Focus on each of them individually. And we'll do that first just because it helps us kind of organize our thinking. And then we can do another way where it's just kind of straightforward, or just one long calculation. So Monday, Wednesday, and Thursday, he cut 5 lawns each day. So $20 per lawn. So rather than write out $20 5 times, I'm going to say 5 times 20. So 5 times 20 on those 3 days. On Tuesday and Friday, he cut 7 lawns. So 7 times 20. Again, rather than adding up 27 times. He had to buy gas 6 times in total. So it doesn't really matter what day we're doing that on. Let's say maybe it's on Friday. He had to buy gas 6 times. So that would have been 6 times negative 15 because we're losing $15. and he had to buy a $10 lunch on 3 of those days. Right, so let's say maybe, again on Friday, we'll do it cumulative. So on 3 days, he bought a $10 lunch, so he had to pay $10. So in total, 5 times 20 is 100. 7 times 20 is 140. And on the last day, we had 140 minus 90 minus 30, which left him with $20 in total. So then the total earnings would be 100 plus 140 plus 100 plus 100 plus 20. So then in this case, in total, he had 100 plus 140 plus 100 plus 100 plus 20. So he had $460 in total. So he definitely has more than enough money for his bike. The other way you could have done it, rather than sorting it out by each day, you could have just done it right as we read it. So total earnings will equal, well, he cut 5 lawns 3 days. So again, that's 5 times 20 plus 5 times 20 plus 5 times 20. On 2 days, he cut 7 each day, so that would be 7 times 20 plus 7 times 20. He had to buy gas 6 times, so that's going to be 6 or plus 6 times negative 15 because we're losing money, and then plus 3 times negative 10 because we're losing $10 3 times for his $10 lunch. And when we go through and we do this again, we can simplify what we've done, but again, in the end, we should still get $460 are his total earnings. So either way you kind of work through this or reason through it, you should still get the same answer in the end. It all depends on how you like to organize your work. In example 5, Georgina loves to golf at her local par 72 course. She earns the same score 3 days in a row, 4 under par. If the club champion shot 204 shots over the same 3 days, did Georgina beat them? So this is going to be a little bit tricky, and you have to have a little bit of an understanding of math. Or sorry, not math. Of course you need to understand math. We're doing a math lesson. A bit of an understanding of golf. So her local par 72 course. So basically that means, generally speaking, you're taking 72 shots to finish the course. So Georgina scores the same thing 3 days in a row, which is 4 under par. And the club champion shoots 204 shots over those 3 days. So in total, over 3 days, the club champion shoots 204 shots. We want to know, did Georgina beat them? Which in this case means lower number of shots wins. Right? In golf, you want to have the lower number. So in this case, we're looking for it. Basically, does Georgina have less than 204 or 204 shots? So how we can figure this out for the shots, we have a par 72, but she's shooting 4 under par. So that means 4 less than 72. So we have to do a small calculation beforehand. Or you could say, well, 4 under par, that's 72 minus 4. That's how much she shot on the first day. 72 minus 4, that's how much she shot on the first day, plus she shot out the same thing on the second day, and the same thing on the third day. You could recognize, well, because we're adding up the same thing 3 times, why don't we just multiply that by? 3 instead of adding it up. So 3 times 72 minus 4. You might have to use a little bit of bed mass. Or we could recognize 72 minus 4 equals 68. So we're going to do 3 times 68 to save us from having to do that extra calculation. Either way, in the end, it all works out to the same thing, which is 204 shots. So Georgina had 204 shots over the 3 days, same as a club champion. Therefore, they tie. So it's a tie between the two of them. If we look at integer-only examples, it might be a little bit difficult when dealing with negative ones. So if we have 3 times negative 2, well, that means we have 3 groups of negative 2, which equals negative 6 tiles in total. Right, so we do have an example of what that would look like. Now it does become trickier when we have, say, for example, negative 4 times 2. We know negative 4 times 2, if we do it on a calculator, gives us negative 8. But is that saying negative 4 groups of 2? That doesn't really kind of make sense. What does it mean by negative 4 groups? But with multiplying, we can switch our two numbers. So when multiplying, order doesn't matter. So I can switch these two numbers. So I can have it as 2 times negative 4 instead, which means 2 groups of negative 4, which makes it a little bit easier to understand or maybe visualize. So I have my 2 groups. Oops. I have my 2 groups here. So 2 groups of negative 4, which is negative 8. But it does become trickier when we have double negatives or negative groups of negative groups. So what does that look like? Well, say for example we had negative 4 times negative 3. So we have our negative 3 groups. And we have, but what would negative 4 groups mean of that? Right? This example here would be plus 4 groups of negative 3, which would equal negative 12. But we don't have plus 4, we have negative 4. So because it's negative, we need the opposite of 4 groups of negative 3, which in this case would be 4 groups of positive 3. So when we have a negative times a negative, we end up with a positive. So in this case, it actually works out to positive 12 tiles. And when we're dealing with integers like this, basically, if we want to simplify, a positive and a negative number will equal a negative, positive, and positive number equal positive, negative and negative number will equal a positive. So when we're multiplying or dividing, we can use kind of this little cheat code. If we have 2 different signs, our final answer should be a negative. 2 of the same signs, our final answer should be positive. So let's take a look at some just integer-only examples and see if we can solve them. So with example C, again, if we're using kind of our cheat code, you could say we have negative 16 divided by 2, so a negative number divided by a positive, so that kind of falls under this first category, where you have 2 different ones. Which means if I just do this simple math, 16 divided by 2 is 8, but because of the 2 different signs, it's going to be negative. You could also say that if I want to take my negative 16 so that's 10, 12, 14, 16, and divide it up into 2 equal groups. How many does each group have? Well, it's -8, or there's 8 negative squares per each one. Negative 25 divided by -5. Again, just doing the quick math, this would work out to +5. 25 divided by 5 is 5. 2 negatives means we have a positive. You could also, again, work out if I have 2 negative numbers, 25 negative squares, and I want to group them up into groups of 5 or -5. So I can't really do -5 groups, but if I do the opposite of that and into groups of 5, I ended up with +5. So again, the double negative is where it gets tricky, where you actually have to then convert that into basically, this becomes then your 4 groups of positive numbers, or your 5 groups of +5. Quickly draw this one out here. Again, I don't expect you to go through and draw a visual for each one, but sometimes it might help. Right? Sometimes it might help visually, and again, I do understand that you do have a calculator that you can use to help you with that. Lastly, a tricky one. We have -5 times 5 times -2 times -3. So what you can do is kind of work through this step by step, right? We're going to focus on the first 2 first, and then we'll multiply that answer by -3. So 5 times -2, we get -10, multiplied by -3, and then when we do this one, we would end up with +30. Visually, if I have 5 groups of -2, so 1, 2, 1, 2, oops. So I have my 5 groups of -2. So in total, I have -10. Now I need -3 groups of this. So if I wanted to do the opposite, or if I had -3 groups, again, it's hard to, how do we really represent -3 groups? This would be if I had +3 groups, right? So if this was 10 times +3, I would end up with -30. But because it is going to be -3 groups and not +3 groups, what we can do here then instead moving some things around here. Instead of having -3 groups, -3 groups of 10, what we can do is we would make these positive. So again, a little bit more difficult to visualize when we're dealing with positive numbers. Hopefully give that a second there. Kind of work out. But the idea is we can make those positive because it's the opposite of what we just had. So instead of having negative 3 groups, or sorry, 3 groups of negative 10, we're having the opposite, so that is positive groups, or positive 3 groups of 10. So again, can be difficult when you visualize, but again, as long as you're understanding kind of what we're doing, you don't need to visualize it unless you really have to. So again, this was taking a look at positive and negative integers. I know it was a little bit of a longer one, so again, just use this as a kind of backup if you are struggling a little bit with positive and negatives and you want kind of a refresher on the material.